So let's go backwards. In the last video, we talked about taking an exponential and making it into a logarithm by using ELB. Now we're going to take a logarithm and make it back into an exponential by using ELB as well. So ELB is effective by showing us where things came from, right? So looking at, the exponent is the logarithm of the base. Remember that the exponent was the number all by itself on the other side of the equal sign. And then on the other side of the equal sign was a log of all that mess. So on one side of the equal, I have a number, which is exponent. And on the other side, I have the logarithm and all the other mess. So if I look at A, this number is by itself. This is my as my equal. And the exponent is on the other side of that equal sign, and that's all alone. So that happens to be my exponent. That's my exponent. Now, what was the base? The base of the logarithm is 5, and it happens to also be the base of the exponential. That leaves me with just the leftovers. Now, for this numerical example, we can actually justify this, right? Because what is 5 squared? It is 25. Oh, snap. So we did this problem very correct. Part B, once again, the exponent. Look for the exponents, right? The exponents are the things by themselves, right? That's an exponent for that problem. This is the exponent for this problem. This is the exponent for this problem. This is the exponent for this problem. It's the thing by itself on the other side of the equal. What was the base of the logarithm? It was 2. And because it's also going to be the base of the exponential, I can do that. And then finally, what's left over is the argument, which is 1/8. Now, again, this is also completely correct mathematically. If you were to take this 2 to the negative third, which is over 1, and if you were to actually bring it down, the exponent becomes positive. And what's 2 to the third power? 8. And that checks out. You do not have to check these, and sometimes you can't really check these, but I just want to have you be comfortable with the idea that what we're doing here backwards with ELB is very correct. So let's go into this willingly and trusting that the exponent is 3 over 2, the base is 25, and the argument is 125. And by the way, if you're not sure of your skills yet, you could take this answer and not look at this at all, and do ELB on this and see if it ends up looking exactly like the original problem, if you really were worried about it. Part D, this is exponent, 2, and then 8 is the argument. And for part E, x is exponent. Oh, snap, where's the base? Oh, snap. I think I made a typo. Oh, snap. JK is actually intentional. So part E is a special type of logarithm. We're going to discuss 2 special types in this class. Here's our first one. It's called a common logarithm. So it's so common that actually if you were to look at your calculator and see the log button, it just says log because it's a common logarithm. You won't see log base 2 or base 3 or log base 5. You'll just see something that says log, and that is known as a common logarithm, and it has a base of 10. But we generally don't write it. So I could have written E, for example, as log base 10, 2, and that would have been the same as what I wrote for E that you see right here, x equals log 2. They're the same, equivalent, identical, believe it or not, problems. Okay, so E is called a common logarithm, and generally for a common logarithm, we don't write the 10 base, but it's understood that the base is 10. So let's go ahead and work with it like this right here, just to make you more comfortable with it. So the exponent is x, the base is 10, and everything else is going to just be 2, the argument. So this is the exponential form of part E. Interesting. You learn something new every day. Well, we did ELB forward and backward. Explain how to use ELB. You may wish... Ooh. That was a typo. Sorry. There must have been a lisp on my part. You may with to create an example of your own. You may wish to create an example of your own. Good golly. Well, let's continue with the shenanigans. So problem 4, look at A through F and notice how these are different from problem 3, A through E. There's a very big difference. And if you're not sure, read the left column idea. I need these, right? When I say ELB, when I say the exponent is the logarithm of the base, that is an equal sign. I need to have equals here. So I need to do equals something. Well, we're evaluating, we're solving. We're just solving for x. So I'm going to make, the answer is not x. That's not the answer. This is the original problem. Okay, log base 216 equals x. So what I do now is I'm going to use ELB to make this into an exponential, and then we can solve it like we showed you before in the past on how to solve exponentials. So this x is going to be the exponent, the base is going to be 2, and it's equal to 16. Now, we've done problems like this before. We have to express both of these in the same base. How did I get this? Well, you could do a factor tree. Regardless, we have the same base, so that means exponents are equal to each other. So the answer to part A is that x is equal to 4. So this is what it means. In other words, if you had a calculator that you could put this into, you would get the answer is 4. But let me show you the technicalities involved here. So with the original problem, right, log base 216, let's say I'm using Desmos to figure this out, and I have to go more technical here and click on function. And there's log. And you see what is happening? It's not asking me for a base. Like, I can't, I'm going to try to maybe backspace this, and let's see if it'll let me do, it doesn't let me do subscripts. I can't make it a small little thing, right? Like, it's not letting me make it like this. I need this to be a little 2 on the bottom, but it won't let me do it. And it's already freaking out. So what's happening here is, let's pretend I just go ahead and put 2, right? Or 4, 16. Oh, snap. 16. See, it's giving me some long decimal. And here's why. What it's doing is it's doing this log button that we have here is a common log button. You only have 2 special logarithms on the calculator. ln, which will tell you when you're older, and log. And this log is just a common log. So we don't have, and if you look at a regular scientific calculator, most of them do not do special bases. They only do ln and log. And so we run into problems here. We actually have problems in math that a calculator cannot do and that a human actually has to do. However, we could trick a calculator, and I'll show you that in the future, on how to do different base logarithms. So yeah, I mean, problem 4 is about how to do logarithm problems that calculators cannot do. So problem 4 could be renamed humans doing what calculators can't. All right, part B, same idea, right? Set it equal to x. That's going to be, the exponent is x, the base is going to be 2, equals 64. I'm not going to do the factor tree breakdowns because you're old enough to figure these out. You can pause the video, do it for yourself. That's 2 to the 6. They have the same bases, so that means x is equal to 6. So what we're saying is if I were to put this in a calculator, the answer would be 6, right? So A, if I put that in a calculator, the answer should be 4. Interesting. Part C, I have 4 to the x power, right? Because I'm going to make this equal to x. Is equal to 2. 4 is 2 squared, and 2 actually has a 1 power. So that means I can ignore the bases and just set them equal to each other. And if I divide both sides by 2, I get that x is equal to 1/2. So in other words, if I were to put this in a calculator, it would be 1/2. Now, here's a good left column idea for you to write on your own to consider. Look what's happening here. When the base is smaller, right? The base is smaller than the argument. I get these numbers. But when the base is bigger than the argument, I'm getting smaller numbers, like fractions. Interesting. Well, what if the argument and the base are the same, right? Let's see what happens. So I have 8 to the x power equals 8. Now, folks, please don't do a factor tree for this. It's the same base, for crying out loud. So this is the power of 1. They're the same base. X equals 1. So if you were to put this in a calculator somehow, you would get that the answer is just 1. So you saw what happens when the base is smaller than the argument, when the base is bigger than the argument, and now you've seen when the base is the argument. And actually, you're going to want to put a star next to part D because that's going to feature in one of your assignments heavily. And when you do get to that point, please make sure to add more information in your notes when you get to those assignments and when you see the patterns that you're observing.